Hey guys, David here and welcome back to the series where I show you how you can build your own keyboards. Up until now we have finished the hardware, but now it's time for the software. What firmware should you run on it? Should you start and code your own thing for Arduino, or should you go with something like QMK that is already done and you have a bunch of functionality? But how do you go about it? In this video I will show you step by step how you can upload your own firmware to your designs and how to customize it and the different options. So if that sounds interesting, make sure to stay tuned. But first off, I want to give a big thanks to PCBWay for sponsoring this series. They make super high quality PCBs at a very affordable price. If you're following along one of the builds that I'm doing here, you can get up to 10 pieces, 10 by 10 centimeters, silk screen, everything for just $5, which will allow you to get into your own keyboards very easily. And if you've never ordered from them before, I have a coupon code linked down below that will give you $5 off, meaning your first PCBs will be completely free and you just have to pay shipping. So if that doesn't sound like a good deal, I don't know what does. So make sure to go check out PCBWay linked down below. Now, if you have not seen the previous videos where I built the PCBs and then went ahead and designed custom enclosures for it, I highly suggest that you go check them out. They are all linked down below, up in the cards everywhere. Just make sure to not close this video and so you do want to come back to it. Where we are left is that we have a PCB that has switches on it and has a ATmega 32U4 microprocessor, but something needs to run on that processor to make sure to read out the switches and then send those signals to the computer. Now that processor is very much compatible with Arduino. So what I did for my very first keyboard, and well, it's actually a very good idea if you just want to get started and experiment with it, is to make your own firmware. Jump into the Arduino IDE. It's not all that hard to read out the switches and to get something up and running. But if you want to make a full-size keyboard and have something more complicated, then you will quickly run into limitations and either put in a lot of development effort, but at that point you're essentially just recreating something that is already out there. There are various different open source keyboard firmware out there, but I quite like QMK, so this is what I will cover in this video. But if you prefer one of the other ones, most of what I do here will still apply, and you can just check out their documentation on how to implement that. Alright, so we're over at the computer now, and in front of me I have an empty Arduino sketch, and that's because I want to show you really step by step how you can code up your very own simple keyboard interface. Not gonna go too much into depth, but I'll just show you how to read out the keys and send keystrokes back to the computer. After that I'll move on to things like QMK and how to program your keyboard. So if you're not interested in one of or the other parts, then you can just use the chapters and timestamps down below to jump between what you actually want to see. So you're probably familiar with this interface if you've ever used Arduino before, and this is what you get when you start it up. The void setup here is what gets executed once, right when the Arduino is first started up, and then afterwards it will just repeat what is in here over and over again. So up in the setup we want to do things like initializations so that everything works properly, and then in the loop is where we want to read out our keystrokes and set them back to the computer. We do, however, need some libraries for this to work, one of which is the Keyboard.h library that is from Arduino themselves that allows you to send keystrokes back to the computer. And the other one is the Adafruit NeoPixel library, and this will allow us to control the LEDs that we integrated. If you're not using LEDs, you can forget about that completely. To initialize the LEDs and get them properly working, you need to include this line here just at the very beginning before everything. Here you're calling this library. Strip is just what you're calling, how you later refer to this LEDs. And here the 6 is the number of LEDs that are in your line. So if you have just a 6 from a very simple example, then 6 here, or if you have 12 from a big one, and then 7 is the pin number where they are connected to. This back here is just for, depends on the kind of LED that you're using, and for the ones that I've showed in the previous ones, you need to use these ones. If you're using different LEDs, you can just Google what you need to put back here. That is just so that the protocol and everything is correct. Then next, I'm just making a simple array here with all the inputs and outputs. For such a small keyboard, this is not necessarily necessary, but if you have a larger one, it is a lot easier to just iterate over an array to initialize all the pins than having to do so manually. So it's a good idea to just have a simple byte array where you put in all the inputs and outputs. The inputs and outputs, that refers to the matrix, as I've explained in a previous video. So inputs would be where it's read out, so that would be the columns for us, and outputs would be the rows. Then to actually address the keys and kind of set up your kind of layout, there's various ways. If you just have very simple keys, then it's easiest to have a two-dimensional array. So basically a table with characters, and then you can just have these in here. This is how you would initialize that here, and then you can just directly call these up. But if you just have very few keys, you can also once again just kind of manually with if statements or if with a switch statement choose what it is and kind of write it out the code. This is just another option of simplifying the code if you have a fairly large keyboard. A final array that we need is once again for all the keys one spot. So I'm using a two-dimensional array here, and that is for key down. What this means is the keyboard will read out every keystroke you make dozens or even hundreds of times, depending on how long you press the key. But we only want to send keystroke the first time and not all the times. So by having this little array here, we can change this value and then check every time to make sure that we only send a new keystroke when it has been pressed for the first time. If you want the functionality of sending multiple keystrokes, if you keep pressing on it, you can also do that by having an additional array where you can count up, and then let's say every 20th time you get to it in the loop, you send a keystroke. That is an easy way to do it, but I will not do that in this video, just to keep it simple. If you want to have more complicated features, then it's probably easier to go something like QMK anyhow. Then here in the setup, the first thing we need to do is set all the pin modes for all of our pins. We can either do that manually, since we only have 5 pins here, but I'm just using a simple for loop here to iterate through, setting pin modes for outputs here. I'm using that array again, and the ith element going from 0 and 1, and then setting it as an output. I'm also immediately setting this output to high. And that is because the way we're using the logic here is that everything is high, and then we're going to pull selective ones low to then read out the keys. Second one here is for all of the inputs. And so I'm iterating through the 3 inputs here and declaring them as inputs and also activating the pull-up resistor. That just means that if they are not being actively pulled to ground, they will read high. To establish connections with the computer, for debugging purposes, I'm starting a serial line here, just the very standard serial communication that you can then, using the little monitor up here, read out. That's good for debugging, but you don't really need it anymore later. And Keyboard.begin will initialize the keyboard library and connect your Arduino as a keyboard device to the computer. Then if we want the LEDs to also turn on right away, we need to initialize the strip by saying strip.begin. That's the strip that we declared up here. And then I'm iterating through all of the LEDs and setting them to 50, 50, 50, which is kind of a white color. You can set them to any color or start any kind of effects down here. That's just what I decided to do here. And then we need to do a strip.show to actually show the colors that we set it to. And that is already it for the basic setup. Now coming to the loop, we need to read out all of our keys and set the respective strokes. To be able to kind of read out a matrix, I have 2 nested for loops here. The first one is iterating through the columns, so we have 2 of those in our example, and then the second one is iterating through the rows to actually read out the individual keys. To start reading out some keys, we are setting one of the outputs here. So first we start with the first output and the second one to low. And that will then result in, if any of the keys are pressed, then one of the input pins will also be pulled low. And after that, we're just doing a very short delay to make sure that everything had time to settle and we are not reading too quickly. So here, make sure that you use the delay microseconds and not milliseconds. This is just a very, very short amount of time and will not really introduce any lag or anything. It's might be able to work without it, but it's just a good thing to put this in here just for safety. Then after we have turned one of the rows low, we want to go in here into the second for loop and go through all of the 3 inputs, or how many ever inputs you have, and read them out. So here in this if statement, I'm doing a digital read of the input, and if it is low, that means that a switch was pressed. Then I'm calling a different function, key pressed here, and sending in which column and which row. This function we have to write later. And this is where we would then send a command to the computer to actually do something with this. Inside of this function here, I will also make sure that the key has been pressed for the first time. But just to keep it a bit more organized here, I'm not doing that up here. But in case that the key is not pressed, that's why I have an else here, I want to make sure to reset the key and ensure that next time it is pressed again, we send the command again. So I'm just calling a different function here in case that the key was previously down. So if key down, that's the thing that we set up before, is not equal to 0. So if the key was down before, then we call this function here. This part here then gets, of course, repeated for all the different rows, for all the different columns. And then after that, we want to switch to the next row. So we need to set the current row high once more. And then I'm putting a slightly longer delay in here. And then we start over the loop, and it goes to the second row and sets that one low, reads out all of the inputs again, and sets it high again. Now, all that is left to do is to actually write those functions that we called earlier. So we have the key pressed here, and I'm accepting an integer for the row. That will be our I variable here that we are passing through, and then an integer for the column. Then for debugging purposes, I'm just gonna start out by outputting it and saying which row and column it is. That's just a great way to kind of figure it out. You can delete those lines later once it was working, or if you don't want to put them in here, you don't have to. Now the main event here is that we go ahead and check if the key has already been pressed before, and we are just rechecking it. So we are checking the key down matrix here that we have created, and if it is 0, that means that this is the first time this key has been registered, and then it goes in here and does a keyboard.write command. That is what actually sends the keystroke to the computer. And here we are just sending the character from our array up here. If you wanted to implement some special cases, you can put another if statement in here and saying, for example, if it is row 2, column 1, then do this instead, and only otherwise do this. But we'll just keep it simple for now. After sending the keystroke, we of course have to also set our key down variable to true, and that is just so that we next time don't send one again. Then the reset key that we did up here also accepts the same input and just resets the variable back to false. Now you could of course also put that up here. I just wanted to keep it very simple up here, and then if you keep adding stuff and keep adding functionality to your code, you can simply add more reset functionality down here instead of making the top loop more complicated to read. Now that we have this very simple code, we can go ahead, upload it to our little keyboard that we built, and it should be working. To debug it, you can use the serial communication up here and just go through your code step by step, make sure that everything is nice and neat. If you want to know more about the various functions that the keyboard library supports, you can go ahead to the Arduino website and check out the documentation for the keyboard library. You can see down here some of the things that we have used, but there are also other functions that we have not used yet. And in case you're wondering how you can send special characters, there's a different page for it that gives you various codes that you can go ahead and send for all the different special characters that might not have one. It also gives a little example here of how you would chain different keyboard press commands together to, in this case, they do Shift F2, but instead of Shift you could also have Alt here and then F4, and you could very easily create your own macros like this. But now I want to talk about something a little bit more advanced. If you have a very simple, easy keyboard that you just want a couple of macro keys, creating your own firmware is all good, but if you're making a full-size keyboard or even just like a bigger project, then using an already finished software like QMK makes a lot more sense, as it means you don't have to create everything from scratch, you don't have to debug everything. I first created my own keyboard firmware and I implemented a bunch of features and it worked most of the time, but every once in a while I get really weird glitches and I just never really properly figured it out. So switched to QMK and I've never had any issues since. Now, of course, switching to something like this also means you'd have to do a bit more configuration and a bit more things, as it is quite a bit more involved. Now, if you are not designing your own PCB from scratch, you can use their QMK configurator, and they have a ton of keyboards that are supported in here, and even if you make your own PCB you might be able to model it after one of the already supported ones, or there are a bunch of hand-wired examples in here as well, where if you can look up how they have wired it and you want to do something similar, if you have the same hardware setup as one of these keyboards, you can just select the keyboard here and then down here create your layout in a GUI. You can just click on whatever key it is and then select down here from all the different things. You can say, hey, this E key, I don't want it to be an E key, I want it to be F7, and then it will update like that. You can set up multiple layers here and multiple keymaps as well. You can then go ahead and just compile it on this directly in this online thing and skip to the final step of uploading it to your keyboard. But if you have created your custom keyboard and it's either don't feel like searching for one that is similar enough, or you have created something that is very unique, then you are gonna have to do a bit more work, sadly. I will not be able to cover every little detail about it, so I will show you here the documentation, and it has a lot of things about all the different steps, and it is really well written documentation. So if you have any further questions, make sure to go check it out. This will be a lot clearer, and I keep referring back to this documentation every time I use it as well, because while I have built a couple keyboards with QMK, I am by no means a master, and I will also not be properly able to teach you all the different features of QMK, just because I don't know how to use them either. The first thing you want to do to use QMK is go ahead to the GitHub repository and either clone it if you're familiar with GitHub and you use it already, or otherwise you can click here and download it as a zip directory and just unzip it somewhere in your documents folder. And then you can work with it as if it was just regular folders instead of anything with GitHub. You will also want a few more tools. The other thing is the QMK toolbox. This is the utility that we use to actually flash the firmware onto our board. And the last one that you also want is a QMK MSys, and that is just a little simple terminal application that we are using to compile the firmware. I'll show you more about that later. When you have downloaded and unzipped your keyboards, it will look something like that. There might be a bit fewer files down here, as I have already compiled a bunch of things, but for the most part the folder structure should look similar. You have a bunch of things up here that you don't really need to worry about. The main thing that you want to check out is the keyboards folder. In here you can see the same keyboards that you found in the configurator before, and these are great examples as you can open it up, look inside, see how they have configured it. The way that I mainly learned how to properly configure QMK is just by looking at a bunch of examples. We'll also, of course, have my firmware linked down below, and you can go through that, and it might be more familiar as it is, of course, for the keyboards that I showed you how to build. But there's many more examples down here if you want to see different features that I might not have used. Then once we are inside of one of the different specific keyboards, we have a couple of files here. The very basic one, config.h. Inside of config.h is where you basically set all of your basic parameters. Up here you see various identification things. You can set the manufacturer and product name. The product name here is what will show up in Windows. Like if you plug it in, it will show up, oh, Lilith 12 is connected. Or if you go into the task manager as well. And same with the manufacturer, you can also see that there. Those IDs up here, you don't have to really worry about. You can more or less set them to anything. They just matter if you are actually shipping a product, then each USB product needs a unique ID, and this is where you would assign it. And if you actually ship a keyboard or ship a product that connects over USB, you need to have the proper rights for these. But if you're just making your own, you can set this to whatever you want. The rest here you can leave mostly the same. What you have to define here is the number of rows and columns, and that is just so the software knows what, and then down here also the pins. Also, I'm showing you this, and the intention is not that you write this from scratch. The way that I do it is just I copied one of the keyboards and then modified it until it worked for me, and now I just each time modify one of my existing configs that I know to work, and then change whatever I changed for the new keyboard. You can feel free to use one of mine, or you can use one of the other default examples. Here in diode direction is if you install your diodes the other way around for some reason, then you can change it from call to row to call. That is just the direction of the diodes that are pointing. For the backlight, that is where your LEDs are connected to, and then here you can set backlight level. That is just how many different brightnesses there are. That is only applicable if you're actually using like RGB backlight or something, and then you can switch through that if you assign a key to changing the brightness. Down here are various other RGB parameters. You have the pin down here. You can set how many LEDs you actually have. You can set how many hue and saturation steps and stuff like that you have. And here, very important as well, you can limit the maximum brightness. Here I have it set to 180. That is a good number if you don't have many keys. But if you're building like a full-size keyboard, then you definitely want to set that lower, as otherwise they might draw too much power. Then the next thing that we need to configure is the name of your Keyboard.c file. This is where you can add a lot of custom functionality if you are into this kind of thing. But if you don't really care about custom functionality, there are still a couple of things that you need to change. For one, you need to update the name of your keyboard in here, as that will make sure that the other script is properly loaded. Then down here is where, for the various steps in the process, like for example, if each time a key gets pressed or the magnet matrix is scanned, this function here is called. And if you wanted to add any custom code, this is where you could ingest that. Down here you can also set some default RGB settings. That is just what it defaults to in the beginning. But you don't necessarily have to set that. The name of your Keyboard.h is another file, and this is where you need to do some more hardware configuration. Essentially assign different IDs to the pins and the rows. And this is where you would, like if you have a very complicated matrix set up, for example, because you have a full-size keyboard, if you have a long and skinny one and you wire up your matrix differently, here you can kind of translate between the rows and columns of your keyboard layout and rows and columns of the pins and how like the controller sees that. For our cases here, there's really not much going on since we are using the matrix exactly like the keys are arranged, so this is just the same, and you can update that to kind of match the same, and you don't really have to worry about this too much. The Rules.mk file you only really have to ever change once. Here is where you set the controller type. It might already be set correctly depending on what you're using, and you can set a few other things like whether you want to be able to send mouse commands or special keys and various other things. Really don't need to worry about it too much. It's just like if you want to use some fancy features, then you might have to enable them here, or if you're not using them, you can disable them to make the firmware a bit smaller and to not confuse a computer with too many different input devices. The info.json file you don't really have to worry about. That is what would tell the online configurator how exactly your keyboard looks, and then it would use this file for you to be able to use the GUI to assign the key commands. But as long as you don't plan on using that, you can completely just ignore this file. And same with README, that's just an information file, just like any README. You can put info in there, or you can just ignore it. Then the last thing we need to do is, of course, set up the keymaps, and this is inside of keymaps. And then here you could have multiple ones set up for the same keyboard, or you can just use the default one. And here, once again, you have a couple of one. Config is basically empty file. README, once again, just README, and Keymap.c is the main keymap file. This up here I have added myself. That is for custom macros, but essentially the main thing that you need, the very basic thing, is down here. You have here you set which layer it is, and then you have layout, and here you have all the different keys that you want to set. Because we had this other file that looked really confusing with all the different pins, now here we essentially have the layout of the actual keyboard and not anymore the digital one. So here would be top left is the macro for hello. I have defined that up here, I'll show that in a second. But if you just have simple keys, you can look at the key codes in the documentation. For example, KC underscore, that means stands for key code, and R would just be the letter R. There's things like plus, minus, the numbers. You can also chain things together, like LGUI is the left Windows key, and then in brackets you would normally just sending that would just send left Windows, but if you then put in brackets another key, then that will be sent as a combo. So here I have Windows Shift left arrow key. That is something that I use to move my windows back and forth on my desktop. But you can do any kind of simple macro key combination like that. If you have something more complicated, like you want to send a string of characters, you can, inside of the process record user thing that is usually found down here, you can set up a switch case with the key code, and then for case, and then here is where you put the name for your macro. So here I have name hello. So if in case it is calling hello, then here it is sending a string hello world. Same as here for sub, and then just sends a string subscribe. You can not just send strings here, you can do all kinds of things. You can just RGB backlighting, you can send really complicated keyboard combos. You could even have move the mouse around and click on stuff. All of that automation you can all do in here. The only other thing you need to do up here is just to set the save ranges for your names here. Just copy this line here, and you can keep adding here with separated with commas, just all of your different names that you are using, and that is just so it works in the end. My C knowledge is not great enough to properly explain why you need to do all of these things. I've just looked at other keyboards and found that they are using that, and by doing that, it ends up working in the end and doesn't give me an error. If you run into, during the compilation, it throws you an error, you can kind of look through your code if it's anything obvious, otherwise compare it with other keyboard examples and the documentation, and you can kind of use that to figure out what you need to change. With that, we have adjusted all the different files that we need to adjust, and we can
then go ahead and copy the kind of path to the keyboard folder. That will make our life in a second a bit simpler. And then we jump over into QMK MSys. It's kind of a terminal application. You can download it and open it up. And when you run it the first time, you need to run a QMK setup to kind of initialize everything. I've already done it, so I'm not going to run it again. And then to actually compile some firmware, you can use these commands. To make our life simpler, I'm just going to navigate into the directory that our keyboard is in. Here, just do cd, and since I copied it, and you can just right-click to paste the path, and then enter this folder. Now that I am in the folder, I don't any longer need to specify the keyboard, so I can just do QMK compile. And then I do still need to choose the key map. Here, if you have different keyboard layouts set up, then you can choose which one you want to compile with. Otherwise, it's just default. And then hitting enter will start the compiling. This will take a second, and it will throw any errors if there are any errors. Or otherwise, if everything works perfectly, then this will create the hex file that you need to upload to your board. In order to upload it to your board, you sadly cannot just use the USB port, as there is no software yet on the microcontroller, so it does not know how to communicate over USB. So instead, what we need is a programmer. I'm using a USB Tiny ISP. These are really cheap. You can get them on AliExpress and Amazon, anywhere. Or alternatively, if you don't want to buy one of these and you have a spare Arduino lying around, you can also program an Arduino to be an ISP programmer. And then using the pinout here, that is the same pinout that we also added to the PCB. Then we can just use this jumper cable, and I'm using some pin hinders on it that just kind of push into the PCB and use that to program it. If you want to reprogram an Arduino, you can actually reprogram a regular Arduino with the custom firmware as well. Then you can just use individual jumper cables from these pins here to the respective pins on the Arduino. They should either be labeled, or otherwise you can just look up the pinout for your Arduino, and then you will find where you need to connect those. To actually program it, we'll use a QMK toolbox here. And here you can select the controller you want to control, and then up here you want to select the firmware file, so you can just click on open. And if we are here in the QMK firmware folder, up here on the .build, here is where all of your hex files are, and then we can just select the one that you exported, click open, and then if you actually have everything connected, you can then click on Flash, and this will upload the firmware to your keyboard. Uploading it will take a little bit of time, since the Flash on these microcontrollers is not that fast. For me, it usually takes about a minute to upload and then a minute to check, or depending on how big your program is, it might be like between the 30 seconds and 2 minutes. But it will give you kind of a progress bar. You just need to be a bit patient for it to upload properly. Then after that, it's going to testing. Maybe you get lucky, it works the first time. Otherwise, you need to go back, look at the different steps. Sadly, it is not possible for me to cover in a video all the different troubleshooting steps and everything. For one, the video will be hours long, and two, I have experienced a bunch of different errors, but it's very likely that the ones you are experiencing will be different, since you have slightly different setup. So that's just sadly not quite possible. But if you have any specific questions, you can leave them down in the comments, or otherwise you can also check the documentation. I know I've mentioned this a bunch of times, and you probably are just like me and don't like reading documentations, but it is a lot easier for you to kind of read through here and see all the different options. You can also see all the different cool things that is possible with QMK. Like, I haven't even mentioned most of them here. Like, you can do things all the way to sending MIDI commands and bunch of really cool features, but you can go ahead, check those out on the documentation.
So I hope this overview helped you out to get started making your own firmware and getting your keyboard up and running. If you have any more questions, leave them down below in the comments and I'll try to get back to you. Or if you have any suggestions for future videos and things you want me to cover, also please leave them down below. With that said, make sure to subscribe, since I'm pretty sure this is not going to be the last keyboard related video. And also, if you like this video, leave a like down below. I really appreciate it. With that said, thank you guys for watching, and until next time.